So we multiplied radicals. Today we're going to divide them, but it's not that bad because multiplication and division are the same, right? Technically. Okay, step 1. We are first going to divide or simplify inside the radical. So we're going to take care of the stuff inside the radical first, get it as small as possible. And then we have done this before when there's a fraction in the radical. We get to break up the radical. If there is still a fraction inside. And last but not least, our last step is always to simplify. Okay, so we're going to first divide or simplify what we can to get the radical as small as possible. Then we're going to break it up, and then we're going to simplify again. So, example 1. We need to look inside the radical first. We have square root of 11 over 49. Can I reduce 11 over 49? I can't. No, I can't. I cannot. So, we're skipping the step 1 and we're going to go straight to step 2, breaking it up. So, this is the same as square root of 11 over square root of 49. You should remember this, right?
Yes.
Okay. Can I take the square root of 11? No, so it stays as square root 11. Can I take the square root of 49? Yes. 7. So that's my answer. Square root of 11 over 7. Fractions are our friends, right guys?
No.
So you can leave your answer as a fraction. Okay, so that's your answer. Okay? You guys good? Okay, example 2. Square root of 60 over 5. Can I reduce that? I can. 5 goes into 5 how many times? Once, and 5 goes into 60 12 times. So this is the same as the square root of 12. Can I reduce that more? Yeah, square root of 12. How can I rewrite it? 4 and 3. So square root of 4 is 2, so my answer is 2 root 3. If on a test you left it as square root 12, minus a point because you need to simplify as much as possible. Okay? So it has to be written like this. You guys okay so far?
Yeah.
I want you to try example 3 by yourselves. See if you can do it. First of all, can I reduce 120 over 121?
No.
That doesn't reduce, right? So what's my next step? Break it up. So let's break it up. Square root of 120 over square root of 121. Who got that step so far? Everybody should have done that, right?
Yeah.
Okay. Can we simplify the square root of 120? 30 times 4. Yeah, that works. So this is square root of 30 times 4. What about square root of 121? 11. All right, square root of 4 is 2. So this is 2 root 30 over 11. I can't simplify root 30 anymore because the only things that breaks down to is 3 and 10, neither of which are perfect squares, and 2 and 5. Those are not perfect squares, or 2 and 15, or 6 and 5. None of those are perfect squares, so that's our answer. Did anybody get it right? Root 75a. Can I reduce that at all? I'm going to go with no. So let's break it up. Square root of 75a over square root of 49. Okay, does square root of 75 break down? Yeah. What does it break down to? 7. No, 75. 25 and 3. So this is 3 times 25 times a all over square root of 49. 7. Everybody with me so far? Okay. What is the square root of 25? 5. So that is 5. square root. Can I take the square root of 3 or the square root of a? The answer is no, right? So inside 3a over 7. That's your answer. Okay, so example 5, we have square root of 3s to the third over 27s. I can reduce this. How does it reduce? 3 and s, right? 3 goes into 27 how many times? 9. And s to the third and s, how does that reduce? It reduces to s to the second. So let's rewrite it first. Square root, what's on top? S to the second over, what's on bottom? Just 9. So now what do I do? Let's break it up. Square root of s squared over square root of 9 is, can I take the square root of s squared? I can. What is it? S. And what's the square root of 9? 3. Okay, everybody still with me? Okay, so try 6. Alright, does the inside of this reduce at all? Yeah, let's look at 63 and 7. How does that reduce? 7 goes into 7 once, and 7 goes into 63 9 times. What about y and y to the third? It becomes y to the second, and they're on bottom or on top? On bottom. So this reduces here and becomes y to the second. So let's rewrite it first. Square root of 9 over y squared. Is that what everybody got? Yeah. Okay. Let's break it up. Square root of 9 over square root of y squared. And then this should be easy. Square root of 9 is? 3. Square root of y squared? Y. Who got it correct? Excellent. Okay, have you noticed anything about all of our answers so far? Especially considering the denominators. Look at the denominators. They're all odd. They were all ended up becoming what? If we had a denominator, they were all perfect squares. Did you notice that? It always worked out in the denominator. We could take the square root of that. We could take the square root of that, right? So what happens if it's not? So turn the page. So, okay. So if you ever get a fraction in the denominator, there are some big no-nos, right? What's one no-no of fractions? No zero in the what? Denominator. So in a fraction, the denominator cannot be 0 or, and I forgot to add this on your notes, or a root. So now we have another big no-no for fractions. Remember, we could never have 0 in the denominator, and now we also know we cannot have a root in the denominator. So what we are going to do is called rationalizing. So if you ever get it to where the denominator has a root in it, you're going to multiply the numerator and denominator by the denominator. So whatever's in the denominator, we're going to multiply that on top and on bottom. So we are going to then simplify the root and then simplify the fraction. This is going to make everything work out really nice for us. Okay? So it's not as complicated as it sounds. So let's look at, oh, I didn't write the examples. Oh, darn it. Okay, so this would be example 7. Okay, so example 7. 5 over square root of 5. Can I have that? Is this allowed or not allowed? Not allowed because there is a root in the denominator. So what we're going to do is rationalize, which means I multiply the bottom by square root 5, and I multiply the top by square root 5. Whatever is in the denominator, I multiply. Okay, does anybody see what's going to happen when I do this? They're going to cancel, right? So what is 5 times square root 5? 5 square root 5 over, and we did this yesterday, square root of 5 times square root of 5 is, they cancel each other out, so it's just 5. So we got rid of it. Can I simplify?
Yes.
Yeah, 5 and 5 cancel, right? So what's my answer? Square root 5. It's not always going to work out where those cancel. It just so happened in this problem. But you do need to simplify. Let's try another one. Example 8. Okay. We have square root of 3 over square root of 5. This is not allowed, correct? Okay, so what do I need to multiply by? Square root 5x. So we're going to multiply the bottom by square root 5x and the top by square root 5x. Why do I have to multiply top and bottom? Does anybody know? Yeah, it's the same idea as what you do to one side, you do to the other. Whenever I have a number over itself, what does that reduce to? 1. So technically this is just same as 1, right? So I'm really not changing the value of anything. I'm just rewriting it in a different way. But make sure whatever you do to the bottom, you do to the top. Okay, so that becomes what? Square root 3 times square root 5x. That is square root of 3 times 5x over square root 5x times square root 5x. 5x. It will always work out that way. So what's in the numerator? Square root 15x over 5x. Can I simplify any more? No. So I'm done. Okay, so example 9. 2 root 2 over root 5n. What am I going to rationalize by? Root 5n. So multiply top and bottom by root 5n. And once again, guys, this is called rationalizing the denominator, which means you're getting rid of the radical. Okay? Okay, so what is on top? This is 2 square root 2 times 5n all over root 5n times root 5n. 5n. It's always going to cancel that way. Always. Okay, equals 2 square root 2 times 5n, 10n over 5n. Can I reduce it all? No. This is inside the radical and this is not, so you can't reduce them. So you just leave it how it is. Feel better about it? A little bit? Okay, let's try 10. What will I multiply by? Root 12. So top and bottom. Multiply square root 12 over square root 12. That is 12 root 12 over what?
12.
Over 12. How can I simplify? The 12s cancel. So this is just square root of 12. So that's my answer? No. How does this simplify even more? 4 times 3. So 3 times 4. So what's my answer? 2 root 3. So make sure that you simplify all the way every time. Okay, so try 11. Okay, what do I do first? Multiply by square root of 20y. Top and bottom, right? Okay, so far everybody good? Okay, this becomes, in the numerator, 5 square root 11 times 20y over what? 20y. Who got it so far? Still good. Okay, so what is in the numerator? 5 square root 220y over 20y. Okay, now what? We can simplify 5 and 20, so why don't we do that? But actually, before we simplify 5 and 20, why don't we simplify the root first? How does the root simplify? Did anybody figure that out? 55 times 4. So this is 5 square root 55 times 4 times y all over 20y. So what can I pull out? The 4, and square root of 4 is 2. So this is 5 times 2 square root 55y over 20y. Okay, so that becomes 10 root 55y, and remember the y is inside the root, all over 20y. Okay? Then how does it reduce? 10 goes into 10 once, and 10 goes into 20 twice. So this becomes square root 55y over 2y. Can I simplify the y's? No, because this one is inside the square root, and this one is not. So our answer is left like that. Did anybody get it right? Did anybody get it right up until, I think the trickiest step is right here. Okay, so just make sure that you're simplifying it all of the way. Double check everything. Okay?